Welcome to Maths Misfit, and I am Meena teacher here. Now today, this video, I am going to take something about logarithms. This is part 1. Logarithms is also called as logarithms, or sometimes in short, we call it as logs. So what are we going to do today will be some basic concepts, some properties and laws, and a few simple problems based on these properties and laws. Okay? The first thing that you need to know are some important concepts and logs conversions. So what are these concepts that you need to know before you start with logs? The concepts to be revised and which should be very clear to you are index numbers, algebra, number system. So in algebra, everything that you have done in your school days, even for the number system, everything what you have done in school days about rational numbers, irrational numbers, and for index numbers also. Now, logarithms is generally used to simplify complicated problems, like what I have given you in this case here. Two examples that I have given. Now, these are complicated numbers. So, what do we do with this? Difficult to solve them. Nowadays, of course, you have calculators and all that. But if you have to do it without the calculators, then we use logs to simplify such problems. The next thing that you need to know is index numbers. How are index numbers and logs related to each other is what I'm going to teach you in this part. So you have an index number a raised to n. You all know that a is called as the base and n is called as the exponent or the power or an index number. So you have an example which I have taken. A raised to x is equal to 1. Conveniently, we can write it as y is equal to a raised to x. Now, I have done this. You need not do it. But how do we convert this index number to a log? So what I've taken here is something very, very simple. I have put it as y is equal to a raised to x, which you can see, which I have written in blue. Simply put log y. Now the base of the index number comes as the base for the log. So this becomes log of y to the base a, and the power or the index number comes as your answer, which is the integral value. So this whole thing can be written like this. Log of y to the base a is equal to x, which I have written here. And it is read as log y to the base a. Now, this is converting an index number to a log, but you can have vice versa. So if I need to convert a log to an index number, which I have taken in my second example, log of 81 to the base 3 is equal to 4. So do away with the log 3. So 81 will be equal to the base of the log becomes the base for the index number. So this answer comes to 3 raised to 4 is equal to 81. And you all know that 3 raised to 4 is nothing but 3 into 3 into 3 into 3. Okay. So in the second part, we have converted an index number to a log and a log to an index number. You will be using this at a number of places when we solve the examples. Okay? Now the next thing that you need to remember, when no base is mentioned, then it is taken as 10. So when I have something like log 10 to the base 10, it is equal to 1. Similarly, log 100 to the base 10 will become 2, and so on. The other important thing that you need to know is logs of negative numbers and 0 are not defined. So if you have something like log of -5 or log of 0, then they are undefined numbers. Properties and laws of logarithms. All right. The first one, log of xy to the base a. Now when we say xy, it is understood as x multiplied by y. So this comes out to be log of x to the base a plus. The multiplication becomes a plus, and just like how you open out brackets in algebra, except the difference is instead of the multiplication, it becomes plus. So log of x to the base a plus log of y to the base a. I've taken an example here. Log of 3 multiplied by 2 to the base 5. So you open out this bracket, it comes out to be log of 3 to the base 5 plus log of 2 to the base 5. Now it can be used both the ways, vice versa also. So sometimes in your problems, if you are given log of x to the base a plus log of y to the base a, you can simply write it as log of xy to the base a. Come to the next property. Instead of multiplication, we have a division. The division becomes minus. So I've taken the second example here, log of 3 upon 2 to the base 5. This becomes log of 3 to the base 5 minus log of 2 to the base 5. Now the third one, a very, very important property. Any number, any log to the same base is equal to 1. All right. Example, log 3 to the base 3 is equal to 1. A very important property, log of 1 to the base a or log of 1 to any base is 0. Now this is an important property here. If you look at this, you have log of x raised to y. Now your x raised to y is an index number. So log of x raised to y to the base a. What happens here? The y which is raised to x comes in front here like this. So this becomes y log x to the base a. Look at the example. Log of 2 raised to 4 to the base 3. So what happens over here is that this 4 which is there as the index number comes here. Okay, so this will become 4 log 2 to the base 3. Our next property, log of x to the base a. Now it is the log of a number x to the base a. In the reciprocal, the a and the x change their positions. So this becomes log of a to the base x. Example, log of 3 to the base 2 will become log of 2 to the base 3. The next example, log of x to the base a. Now if you look at this, there is something which I have done here. I have made both to the same base. Log of x to the base p upon log of a to the base p. Now when the bases can be taken as same, so this will simply come out to be log of x upon log of a. Take this example, log of 5 to the base 3. This simply becomes log of 5 upon log of 3. Now if you look at this next property, you'll see that the log is in the index number. A raised to log of x to the base a. So when you take this example, this property, you have the base of the log also the same as the base of the index number. In this case, log also goes away, a also goes away, and simply you're left with x here. So this becomes 2 raised to log 3 to the base 2. Now when you look at this example, the base of the index number 2 is the same as the base of the log number. So this becomes answer as 3. The last property, it's like the 8th one, except that the index number log y to the base a and the base over here x, they are different. In the previous one, both were the same. Now in this case, what happens? Simply the y and the x change their positions. So you'll see what we get. Y raised to log of x to the base a. Take a simple example. 2 raised to log of 3 to the base 5. What happens here? The 3 and 2 will interchange their positions. So this will become 3 log 2 to the base 5. Now, these are all the properties that you need to know while doing your problems. So, revise these and keep using these properties in your sums when you are practicing. So, I'm taking a few solved examples. The first one, evaluate log of 0.01 to the base 100. Now this is when we say evaluate. What is the meaning of evaluate? Evaluate simply means that you have to get your answer in some value. Okay? So now what is that value? You have to find out. So the first thing you do is convert that 0.01 into 1 upon 100. And then convert that 1 upon 100 into an index number, like what I have done here. Now use your law. Which is the law that you're going to use here? Log of any number raised to, say, m to the base x is going to be equal to m log a to the base x. So what happens is this m has come here. Likewise, what will happen over here? This -1 will come here. And log of any number to the same base. So the next law that we have used is log of any number to the same base is equal to 1. So we have used two laws here. And final answer is -1. So out of those 9 laws, we have used 2 laws here. And sometimes you may use 1 law, sometimes you may need to use 3 laws. So depending on the sums that are given to you, you will decide what laws to use. Second example, log of 128 to the base 8. Now evaluate this. So we all know what is 128? It is nothing but 2 raised to 7. And what is 8? 8 is nothing but 2 raised to 3. So what I've done here, I have converted 128 to 2 raised to 7 and 8 to 2 raised to 3. Now, using our law, the 7 and 3, over here, this becomes 7 upon 3 log 2 to the base 2. Now you know log 2 to the base 2. We are using the same law what we have used here. This becomes 1. So your final answer is 7 upon 3. We come to our next sum, which is given here. So our first step, log 3 to the base 5, can be written as log 3 upon log 5. Now the law that we are using, log of a to the base b, can be written as log of a upon log of b. The same thing we have done with log 27 to the base 25 to the base 27. So in our next step, we have got log 3 upon log 5 into log 5 raised to 2. Now that 5 raised to 2 has come because 25 can be written as 5 raised to 2 and 27 can be written as 3 raised to 3. So using the same law, we have got this as log 5 raised to 2 upon log 3 raised to 3. So what happens over here? The next law that we have used in the next step is log of 5 raised to 2 can be written as 2 log 5. The law that we have used here is log of a raised to m is nothing but m log a. Same thing happens with log 3 raised to 3. Now here we have got this log 3 and this log 3. That can be cancelled. In the same way, we have log 5 and we have a log 5 here. That will go. And our final answer will be 2 upon 3. So we have used 2 important laws here. This is the first one and this is the next one. Okay, we go on to the next sum. Now this is an equation given to you. You have solved a lot of linear equations, simultaneous equations also. But if you look at this, we have just one variable and that is x. Look at both the sides. You have logs at 3 places, but over here, there is no log. Okay, so what are we going to do here? Instead of this 1, we will be putting log 10 to the base 10, which I have done here. Okay, now the law that we are going to use in the next step is log of x plus log of y is nothing but log of x, y. That was the first law that we did. Okay. So what happens over here? Literally like how you'll see that there is a log 10 and a log 10 on your LHS and RHS. Now you don't need to cancel it, but mentally just put it this off. And what you get is something like this. 3 into bracket 4x plus 1 is equal to 10 into bracket x plus 1. Solve this as a linear equation and you will get your answer as 7 upon 2. Now you can get a number of sums of this type. That is, you are given an equation in laws. You have to do away with the logs. Remember that you have to do away. That means you have to eliminate the log part and get your equation in a simple linear format. Once you get that, you will get your value of x easily. Okay? Good day to you, and do not forget to like, subscribe, and share this with your friends and all those whom you know are appearing for their competitive exams. See you in my next video. Bye.